Sure, there's sledding, snowmen, skiing, but a winter storm can also mean safari.
You really just need a snowy day. Take a magnifying glass, go out, and there's all sorts of different things you can see.
That's Ken Liebrecht. He's a physicist at Caltech who also happens to be a snowflake expert. He's been hunting flakes for years and documenting them before they melt with this microscope camera rig.
I travel with that. The hard part is getting it through airport security.
Snow crystals come in roughly 35 flavors, Liebrecht says. Some more common than others, of course.
Stellar dendrites are pretty common. These are your standard sort of shopping mall snowflake with 6 branches.
Then there's the variant, fern-like stellar dendrites.
And they look like little bitty ferns.
Also common are
needles and columns. One of my favorites are capped columns,
which look kind of like a satellite or
2 wheels on an axle. Unfortunately, the most common thing you'll find is just kind of junky-looking snow that looks like sand.
The least common, the ivory-billed woodpecker of snowflakes, is big.
5 millimeters in diameter, nicely symmetrical with lots of intricate markings. Those are really gorgeous, and they're hard to find.
But you can increase your chances if you seek out snowflake hotspots.
Northern Ontario is a good spot. Vermont and Michigan have their merit. Northern Japan actually is pretty good. Kind of anxious to try Siberia.
See, certain conditions breed better crystals.
The best temperature is around 5 degrees Fahrenheit. Sometimes, though, you can see really nice crystals just below freezing.
Okay, a little review of where snowflakes come from. They're born in the clouds. It all starts with a speck of dust or a bacterium.
Gunk in the air.
And the gunk floats around the cloud
for half a mile,
picking up water molecules.
And they shuffle around a little bit until they find the right spot to sit in, and then the water molecules themselves are lined up in this little hexagonal array. That's where the order is generated.
And that order is what makes it a crystal.
And as it grows larger, the points of the hexagon stick out a little bit into the air, so each of the 6 corners sprouts an arm. And that's sort of one of the things we're trying to understand in detail, is just how crystals grow.
The details of that growth are determined by the microenvironment the flake encounters as it travels through the cloud.
When the humidity is low, the crystals grow slow, and when the humidity is high, they grow fast.
In other words, a flake's identity is shaped by the environment it grows up in. And because 2 snow crystals aren't likely to follow the exact same path, you're not likely to find 2 of the exact same flake. Just how environment affects crystal growth is something Liebrecht studies in the lab by growing his own snowflakes.
We call these designer snowflakes. You can sort of dial up what you want.
Give it the right environment and something to grow on, and it'll build itself.
It's a really nice example of how really complicated structures can just emerge spontaneously. It's not alive, it has no DNA or anything like that, no genetic code. It just happens. If we understand more about how it works, we'll be able to use it for something, or at the very least, we'll just understand how it works.
Happy New Year. For Science Friday, I'm Flora Lichtman.